A rectangle has one corner in quadrant 1 that is on the graph at 25 minus x squared. How do we graph 25 minus x squared? We're going to go 25 up, so I'll just put a 25 there, and then and then because of the negative, we know it's going down. It's in quadrant 1. What does that mean about my picture?
Is it right here?
Yeah, exactly. We don't need to worry about this part. We just need this part. Okay? And let's go ahead and...
So technically saying that like x is...
How we have to make a
bigger than
rectangle?
0?
Yeah. So I have x comma what?
25 minus x squared.
25 minus x squared. All right. Where's my other point? Next one.
0, 0.
0, 0. Okay, what now?
Who's winning? Okay, a third on the positive
Okay,
y-axis.
where should we, because I drew my point here, where should I draw my point?
Exactly across.
Exactly across, because for a rectangle, right, we have 90-degree angles. So for my, yep, and then directly down. So that's going to be the fourth on the x-axis. What do you guys think? Everybody okay with the rectangle? You're good. Coco's got this. Okay, so now we want to express the area of the rectangle as a function of x. First of all, what is the area of any rectangle? Base times height. All right, but what is our base here? This is x. And our height? Our height is y, but we know our y is really 25 minus x squared. Okay, so then our area is going to be 25x minus x cubed. Easy peasy, right? Okay, so let's talk about then the domain of the area. What do you guys know about any area of any figure, about the possible values it could be? Could it? Can you have an area of negative 36?
No.
It has to be positive. Could it be 0?
Yeah.
No. What would an area of 0 look like? Absolutely nothing, right? So then we wouldn't have a rectangle. So the area does have to be positive. It has to be greater than 0. So we know area is greater than 0. So it wants us to specifically find the domain of A for this situation. So let's go to your calculator. And we're going to type in our area function, 25x minus x cubed. And then we're going to take a look at that graph. All right, what are we going to need to do here? Right, I personally prefer not to zoom out because that's going to change x and y. Change minimum and maximum of which value? The y, all right? What do you guys want to change it to? All right, so I'm going to go negative 100 and positive 100 so that I'm going down 100 and up 100 for my y min, y max. We take a look at the graph, and sure enough, that's a much prettier picture to look at. So I'm going to draw a sketch over here. And my sketch just kind of looks like this. Okay. So here's the thing. All right, here's my sketch. And this is what the area looks like. Okay. Now, when is area positive for this diagram?
Is it 0, 0?
Where does it start positive?
Oh. Yeah, after 0.
All right, so we have this section, but where else is it positive?
Oh, at the bottom section. Wait.
So, yeah, what values of x is y positive? Let's start there. If we go from left to right, what do we call this? Negative infinity to whatever this 0 is here. Does that make sense? All right, so this is where A is positive. Does that make sense? So everything above the x-axis is positive, right? Everybody agree area is positive here? Okay. Why are we not going to use this part?
Because it's negative.
Because what's negative? No, the area is positive here. It's
Because
above
the area
y.
can't
See,
be
area
negative.
is 1, 2, 3, 4, 5,
The
6.
area
It's
can't
going.
be negative.
but the area isn't here. The area is negative. Everything underneath the x area, it has to deal with the negative x. Here, x is negative, right? But what restrictions did we have on our graph?
It has to be in quadrant.
All right, our rectangle has to be in quadrant 1. We have to have a positive x value for this situation. So therefore, when I look over here, I do need a positive area, but I also need x to be positive as well, all right? And so what's going to happen is I can go ahead and ignore this section of the graph, all right? So when we're trying to find the domain of A, we're really trying to figure out what this piece is. This is going to be our domain of A. All right, so let's come over here. And what are we going to have to do to find that? We need to figure out the zeros, okay? So we're going to go second trace 0. Now this one looks like it's on 0, 0. I'm going to make it just go between -1 and 1. So left bound -1, enter. Right bound, I'm going to press 1, enter. So you can see my 2 arrows. This is between -1 and 1, and I can guess, I think it's 0. Sure enough, 0, 0, okay? So this is what it means. Well, you would find, it would give you the 0, right? So we have this point here is 0, 0, and now I want to find this point. So second trace 0. Now if I count, I have 1, 2, 3, 4, 5. So this is really close to 5. So I'm going to make my left bound 4 and my right bound 6 because I know 5 is in between 4 and 6. So left bound 4, right bound 6, and my guess is it's close to 5, and it's exactly 5. So this is 5, comma 0. Good so far?
Yeah.
All right, now we are trying to find the domain of A. So for what x values do I have a positive area?
0 and 5.
Can I include 0 and 5?
No.
Why not?
That's 0.
Because if I include 0 and 5, the area would actually equal 0. So we need parentheses here. The domain of A is between 0 and 5. Okay? Good so far? Okay, so now what we want to do is we want to find for what value of x is A the largest. So we know x has to be between 0 and 5. How are we going to find the largest area possible? We use the max. So we come back here, second trace. Okay, so then we want to use maximum, which is 4. So I'm just going to press 4. And I know my maximum's between 0 and 5 because that's my actual domain. So I'm just going to press 0, enter, 5, enter, enter one more time. And then we get, for what value of x is A the area the largest, that's x equals 2 point, they'll probably have you round to 2 decimal places, so we're going to go 2.89. All right. So 2.89, and then it doesn't say here, but we can just say the largest A is approximately 48.11. So the largest approximate area is 48.11, and that happens when x is 2.89. So if I come to my graph here, right, if x were 2.89, if we plotted that point for point P, that would give us the largest rectangle using this graph 25 minus x squared. Does that make sense? Yay, nay? Yeah. Okay, perfect.